All right, let's jump right in. We're going to tackle a huge question today. Why do so many AI projects, after all the hype and investment, just fizzle out? Well, the answer, more often than not, is because people are building their AI platforms completely backward. So today, we're going to cut through all that noise and give you a clear, use case-driven blueprint that actually works.
This right here, this one idea, is the foundation for everything we're about to talk about. See, what usually happens is companies lead with the tech. They go out and buy the flashy new GPUs, the expensive software, and only then do they start looking for a problem to solve with it. We're going to flip that script entirely.
So that leads us directly to this massive trap that so many organizations fall into. We call it the AI infrastructure myth. And honestly, it's probably the single biggest reason that promising AI projects never even get off the ground.
Now, I know this sounds almost too simple, but the impact is absolutely massive. When you lead with technology, you're putting the cart way before the horse. You end up with these incredibly expensive, over-engineered systems that don't solve a real business problem. And what does that lead to? Wasted money, frustrated teams, and AI projects that have no chance of ever scaling.
Okay, so if that's the wrong way, what's the right way to even begin? Well, you start by taking a good, hard look at what you already have. We call this building your AI runway. And let me be clear, this is not about making a tech shopping list. It's about an honest assessment of the foundation you're standing on right now.
So think of your runway as having 4 essential layers. We're going to walk through each one. You've got the raw horsepower of compute and storage, the critical organization of a container platform, the actual AI platform itself, and then the discipline to scale it all, which is MLOps.
First things first, the absolute basics. Do you actually have the right mix of CPUs and GPUs for the job? Is your storage set up for the kind of intense workloads AI brings? And maybe most importantly, can your internal network, that east-west traffic zipping between your servers, can it handle the fire hose of data that modern AI demands? Next up is orchestration. Do you have a control plane like Kubernetes or OpenShift? Because without it, every single AI deployment is a painful, manual, one-off job. It's totally brittle and completely impossible to scale. A container platform is what lets you manage all these complex pieces without losing your mind. And this is the exact problem we are trying to avoid. When you don't have that control plane, when you don't have a real MLOps strategy, you inevitably create these islands of AI. They might be really cool science projects, sure, but they are not production systems. You can't repeat them, you can't govern them, and you can't scale them, which means at the end of the day, they just don't deliver any lasting business value. All right, so we've assessed our runway. We know what we're working with. Now, we get to make the most important pivot in this whole process. We are going to stop talking about technology and start talking about value. This is the question that changes absolutely everything. Are you trying to build an intelligent search for your internal documents? A system that can watch video and understand what's happening? Or maybe you're tackling something really complex, like agentic workflows, which is just a fancy way of saying AI that can automate tasks with multiple steps. The second you define the what, the how gets a whole lot clearer. And this is the fundamental mind shift. You don't pick an architecture and then try to cram a use case into it. No. You start with the business goal, and that goal literally pulls the right technology components into the design. The architecture just naturally flows from the business need.
Okay, I get it. That might sound a little abstract. So let's make it super concrete. We're going to look at 2 very different use cases and see how they demand 2 completely different architectures. So on one side, we've got a pretty common project, an HR chatbot that answers employee questions. And on the other, we have a system that needs to watch video footage and create a structured transcript from it. Both are AI, right? But what they need to function, worlds apart.
For our HR chatbot, the whole architecture is built around interaction. It needs a vector database so it can search through all the company HR documents. It needs conversational memory so it can remember what you just talked about. And the core technique is something called RAG, or Retrieval Augmented Generation, which sounds complicated. But all it means is the AI is smart enough to look up the facts before it generates an answer.
Now, the video transcriber, that's a totally different beast. It's multimodal, which means it has to understand video and audio at the same time. And that demands a much bigger, more complex model. And its output isn't a conversation, it's structured data. So a traditional database makes way more sense. Here, the game is all about raw GPU power and having really solid data pipelines. And there it is. That's the payoff.
The conversation is no longer some abstract circular debate about which GPU is best. It's a focused, practical discussion about what we need to make the HR chatbot work and what's required to make the video transcriber perform. The architecture just emerges from the demand. It's that simple.
So now that we see how this works for a couple of examples, let's zoom way out. Because this method isn't just for chatbots and transcribers. It applies to literally every industry out there.
Take manufacturing, for instance. A predictive maintenance system, which is just analyzing sensor data over time, might not even need a vector database. But automated quality inspection, a computer vision task where you're comparing images of products to a library of perfect ones, oh yeah, you absolutely need powerful GPUs and a vector database to make that comparison happen in real time. Even inside one industry, the use cases demand different setups.
And this pattern just repeats itself over and over again. It doesn't matter if you're in retail trying to personalize recommendations, in finance detecting fraud, or in healthcare analyzing medical images. The specific tools might change, but the method, starting with the use case, is always the same.
As we look across all these patterns, one component keeps popping up again and again, the vector database. And I think this analogy on the screen just says it all. For any AI that needs context, that needs personalization, that needs search, a vector database isn't a nice-to-have. It's the system's long-term memory.
So, when you boil all of these blueprints down, you start to see a core set of needs that are almost universal. You're almost always going to need a vector DB for that memory, Kubernetes for scaling, GPUs for the heavy lifting, and a solid MLOps framework to make sure the whole thing is repeatable and well-governed.
And that really brings us to the end of this journey. We've gone from a flawed, technology-first approach to a much more robust, value-driven one.
This right here is the ultimate transformation. By focusing on the use case first, you finally stop creating those disconnected one-off islands of AI. Instead, you build a shared, scalable platform, a true AI factory that consistently and efficiently pumps out real business outcomes, not just cool science experiments.
And that's really the final question I want to leave you with. You know your business cases, you know what you need to achieve. So now's the time to take a hard, honest look at your technology stack. Is it just a random collection of parts, or is it a true platform, an architecture that was intentionally designed from the ground up to deliver on those specific outcomes?